Hiwa Dar Mahmoud Management. Hello everyone. My name is Kharman Akram Faraj. I am Professor of Radiobiology, which is meaning also radiation biology. Briefly, I give you some information about the syllabus of this course. وابزان كورس انفورميشن كاش دبر دم تانايا وكوتم اگر عزيزنا به دبر خلالك هي لشاشة كما كورس انفورميشن كاش دبر دم تانا به we give you some information briefly on the course. So first we will go to the course information. After that we will begin with the first lecture. As I said, the course is the course name is Radiation Biology and Safety. You have 2 hours per week on Sunday. When we go back, at home, the lecture will start at 10 to 12. So, but for online, usually at 1 to 2 afternoon. And on Monday, on Sunday. For next week, our online lecture will be on Sunday. I will send you a message also. So بس دكاتي online على الدبودوان هين لابلين يكشمان وبزام أبيد بدوان زي يك بوسي أشتكي ويا دوای بوتانا نيرم بلام إترك هاتي نونا هولا كان بيبا دبودوان زي لصنديا باش. Briefly, we have some syllabus for this course. It is beginning with the introduction of radiation. We will start with this section, which is contain atomic structure, energy dissipation in matter, types of radiation, electromagnetic radiation, and particulate radiation, and what are the difference between these types of radiation. We will explain this section today. After that, we will go to the radiation interaction with tissue. When these types of radiation, we explained in this session, how the interaction occur with the tissue or with the cells or with the living cells. We have some concept we should explain in detail in order to understand the mechanism of interaction, like direct, indirect action, radiolysis of water, because we know that 17% our body is consist of water. The concept of linear energy transfer and relative biological effectiveness is very important to understand the mechanisms of interaction of radiation with tissue. After that, we go to the types of radiation exposure. First, we will go to the source of exposure, types of exposure. We have different types like occupational exposure, medical exposure, public exposure, and the units for measuring these exposure, like KERM, absorbed dose, dose equivalent dose, and effective dose. All of these concepts are the units for measuring radiation, but each type is used for a special purposes. We will explain in details in this session, okay? After that, we'll go to the bioeffects of radiation, like when the radiation incident on our body or the living cells or living organism, how will the effects, biological effects occur, starting with the damage to a DNA. After that, which dose can produce cell death. And we have another, some types of curves called survivor curves. From these curves, we can obtain information about the type of radiation and the doses and the dangers of the different types of radiation. After that, we'll go to the modifying factor, which are the factors affecting the cell survivor, or which are the factors which increase or decrease the effect of ionizing radiation. After that, we'll go to the total body radiation in humans, what will be the effect. and especially the radiation for embryo or fetus. All of these session or these syllabus we will explain in details in future. After that, we go to the radiosensitivity of cells and organs. We know that the radiosensitivity of the cells or organ in inside an individual is different from one organ to another. So when the radiation incident on a part of our body, the different effects occur. Like when radiation is occur on eye, the effect is different when the radiation is occur on liver. So this is depend on their radiosensitivity to the radiation. There is an important law we should concentrate on it, which is law of Bergoni and Tribondio. This law explains for us how our body or our organs, their radiosensitivity is different between them. After that, we go to the how we protect ourselves from different types of radiation. We know that in our country, especially radiation used in medical only for diagnosis and for therapy. So anybody, when they work in these departments at hospitals like radiology department or radiotherapy department, they should know information about protection themselves toward these type of radiation. There is some principle we should concentrate on it, like justification, optimization, and dose limit. Also, there is another rule called shielding time and distance. They have a special rule for reducing the effects of radiation, for exposure. Or organization are responsible for the radiation protection rules. These organizations like ICRP and BR and Atomic Energy Licensee, they put different rules about the radiation protection. We also concentrate on these rules for each agency. After that, we talk about some devices for measurement of or some concept related to the equipment which is used for producing different types of radiation and how we should protect when we deal with the diagnostic X-ray installation in the devices used in hospitals, and some concept like primary shielding, secondary shielding, control booth, half value layer related to and attenuation curves or attenuation coefficients, which has the relation for reducing exposure to these different types of radiation. This is briefly, these syllabus are briefly explained briefly on the syllabus of this course under name Radiation Biology and Safety. This slide is explain your degree throughout the course. You have 20% on week 10, we have group project. When we will go back on halls, we give you some project. On week 10, we have a time now. So, and we have quiz or test, 20% on week 6, and the second test also on week 10. We have 20%. This is 60%. The final assessment, we have 40%. But I think this we will divide it into two examination, 20 by 20. Each of them 120 minutes. This is briefly information about the syllabus. كسب سياري هي الانفورميشن كان زحمة النبي بقوي جذب موضوع كابكين وابزانم اشتكي وايتي انا بو كبسيط بي او فيديوي كبوم ناردو لراستيا وابزانم دوور و درێژیش بوو بۆچی دوور و درێژ بوو لەبەرەوەی بە کوردی شەرحم کردبوو گینا خۆی بە کورت و مختصری دەرئەچێت بە تەفسیلی باسم کردو مۆزوعەکان لە ڕاستیە هەر کەس پرسیارێکی هەبوو ئەتوانێ بیکات نەژبوو بەڕێی من ئێستا ئەگەر هەر پرسیارەکەت هەبوو لەسەر کاغەزەکە لای خۆت بینوسە کە تەواو کرد محاضرەکە بیکە یا لە خلالی محاضرەکان لێم بکە یان ئەگەر ناتەوێت ئێستا بیکی لە لای خۆ بە وەکو نۆت بینوسە ئیشەڵڵا کە هاتینەوە هۆڵەکان بە درێژی بۆ ئەو کەسی باسەکەم کە تێنەگەیشتووە لە مۆزوعەکە. Okay? It's clear for all of you? Okay, nice. We will start with the first lecture, but before we are beginning with the first lecture, I want to explain the name of the course because my specialized or my field is in radiation biology and safety, and I am prof in this field. So I would like to introduce to you the concept of radiation biology and safety. So we will begin the definition of radiation biology, or sometimes called radiobiology. Radiation biology is a branch of science concerned with the action of ionizing radiation of biological, Radiation biology is a branch of science concerned with the action of ionizing radiation on biological tissues and living organisms. Is a combination of two disciplines, radiation physics and biology. In general, my background is physics. I'm not biologist, okay? So this field of radiation biology is the disciplines of radiation physics and biology. This is the study, in other words, we can define that the radiation biology, the study of ionizing radiation, because we have different types of ionizing radiation. Radiation biology concentrate on this type of radiation, ionizing radiation only, on biological tissue and their effects. So this is the disciplines of the two fields, radiation physics and biology. And what we are meaning about the radiation safety, when we deal with this type of radiation, which is ionizing radiation, we should protect ourselves in order not to do any action produce damage in our body. So radiation safety or radiation protection is the science and practice of limiting harmful effects from ionizing radiation on human and the environment. So when anybody work in a place contain ionizing radiation should know the radiation protection tools in order to protect himself or herself from this radiation, because we in our lectures we concentrate on the effects of this type of radiation. It involves minimizing exposure to X-ray, gamma ray. X-ray, gamma ray, radioactive materials are types of ionizing radiation using the principle of time, distance, and shielding to ensure that remain as low as reasonably achievable alara. Radiation biology بريتيل study type ionizing radiation لسر خانەکانی مرۆڤ باشە لەبەرەوە overlappy two field radiation physics and biology هەر کەسێک لە هەر شوێنەکە ئیش بکات ئەبێ معلوماتی هەبێ لەسەر ئەو رادیشنانە خەتەری ئەو رادیشنانە بۆ ئەوەی خۆی بپارێزێ چونکە ionizing radiationەکان بە دۆزی کەمیش و بە دۆزی زۆر نابێ بەرکەوتە بین چونکە ئفێکتی یا درێژخایانی هەیە یا کورتخایانی هەیە لەبەرەوە radiation safety لەگەڵ ئەو دانراوە دایمەن بۆ ئەوەی خۆمان بپارێزین لەو جۆرە ionizing radiationانە کە وەکوتم X-ray و gamma ray و مەسەن radioactive materialەکان لە کاتی خۆیان باسیەکەین بەسمان لە چییە بەچی بە بچ پرنسپلێک تایم هەر شوێنێک ionizing radiation تیابێ هەتا کەمتر لەو شوێنە بمێنیتەوە کەمتر exposure بێ هەتا distance هەتا دوور بی لەسەر چاوەی ionizing radiationەکە کەمتر بەرەکەوی شیلدینیش بۆ هەموو ionizing radiation شیلدینێکمان هەیە بۆ خۆمانی لێ پارێزین ئەم پرنسپڵە زۆر یارمەتیمانەیە بۆ ئەوەی دۆزەکە ببێ بە as low as reasonably achievable بۆ ئەوەی کەمترین بيوتري ألارا كمتين بركوتبي. Okay, this is the definition of radiation biology and safety briefly. We will go to the introduction to radiation. We will begin with the atomic structure. You know, I think this information is very simple for you also. Atomic structure, we mean that the atom is consists of nucleus and electrons. The nucleus contains proton and neutrons. And around the proton and neutrons, there are electrons move around in a special orbit, move around the nucleus. There are some concept called nuclide. When we say nuclide, mean that the proton, the number of proton and neutron. But when we say that nucleons, mean proton is called nucleons, neutron also is called nucleons. This means that this is constitution of the nucleus. But nuclide means that the number of proton and neutron. We have some concept or some symbol used for definition of the atom. A is called atomic mass number, means that the total atomic proton and neutron inside the nucleus is called atomic mass number, denoted by A. Z is the atomic number, which is the total of proton, and usually in each atom, total proton is equal to the number of electron around the nucleus. So the protons are responsible for the positive. We know that inside the nucleus has positive charge, but electron has negative charge. Neutron, they don't have charge. This is E, the charge of electron is equal to 1.6 or 2 multiplied by 10 power to minus 19 coulomb, and rest mass energy, rest mass of proton or neutron is equal to 1.672 multiplied by 10 power to minus 27 kilogram. Usually mass of proton and equal to mass nearly almost equal to mass of neutron. And when we have Z is the number of proton, and when we have an A, which is the number of proton and neutron, when we subtract number of proton from the A, we obtain the number of what? Neutron. And as I said, the neutron have no electric charge. Their rest mass is very close to the proton, and the number of neutron in nucleus is close to the number of proton. This is briefly information about the atomic structure, because when we go to inside the radiation biology, we should go inside deeply on when we say that radiation incident on an organ or cell. When we divided these cells, we reach that these cells contain a complex chemical structure of the molecules, and when we divided this molecule, we obtain atom. So we should know this principle or this information about the atomic structure. This is the structure of atom. This figure, I hope you are with me now. I am on a slide of the structure of atoms. This picture of this figure represent the nucleus and the electrons around the nucleus contain neutron and proton, and electron are on the orbit around the nucleus. After that, we have some other concepts. We should differentiate between them: isotope, isobar, isomer. Isomer called for these types of atom which have the same number of proton, but they have different neutrons. Example, we have carbon 12 and carbon 14. This 12 and 14 is atomic mass number, which include number of proton and neutron. This 6 is the number of proton, or Z. These two atoms, both of them are carbon, but they have the same number of proton, which is 6, but different atomic mass number. When in the first one, which is number is 6 and atomic mass number is 12, this means that number of proton is 6 and number of neutron 6. 6 plus 6 is equal to 12. The second atom of the carbon, which is number of proton is 6, but atomic mass number is 14. This is means that the number of neutron is equal to what? 14 minus 6 is equal to 8. So we call these types of atom isotope. Why? Because they have the same number of proton but different neutron. Another concept, isobar, some number of nucleons, different nuclei. Look on carbon 14 and nitrogen 14, opposite to the isotope. They have different proton, but the same number of nucleon, 14, 14, okay, which had the same number but in different nuclide. This is called isobar. Isomer, same nuclide but different energy stated. Excited versus not excited. Isomer releases their energy in this is related to the nuclide. Okay, technetium, when we see this M beside the atomic number, this is called this atom is in excited state. But when we see technetium without M, this is in a ground state. So when we call these types of atom isomer, the same atom, but one of them are in excited state. When this type will go back to the ground state, emit radiation, especially gamma. Gamma is one of the types of radiation produced inside the nuclide. concept أنا ما هي بالنسبة أتوموا ضرورية بيزانين بو أوي لما عناي راديشن كان بتبقين لما فهمي راديشن تبقين ايزوتوب مان هي ايزوبار مان هي ايزومير مان هي ايزوتوب اگر سيري ادو كربون بكي نفسي اتوميك ما نفسي اجمالي بروتوني هي بلام ديفرنت نيوتروني هي او بيوتري ايزوتوب زور لما عندك لما انا برتشاوت بي بو شويه اگر سيكا مثلا ديفرنتيني هبو اتوميك ماس يترو بروتون كان شيء يكسانا ايزوبار بعكسه ماده اتومك اغوريا ما كربون ونيتروجين نفسي اتوميك ماس بس ديفرنت بروتوني هي ايزومير بو نيوكلايدانا او تري كنفسي اتومن بلام هنديشان لاكسايتد ستيتان لنا من بقولي بس مناو نواتو تشكو ايش يوان لواني يوان ببلام ايزومير بو اتومانا او تري اگر ممشي ويا ام لتنيش اتوم ماسين تكابو او يكسر بيمان عليه شي يكسر بيمان عليه او اتوما الاكسايتد ستيتا لنا نواتا او انا زور فيزياء قولن حسناكم زور بتان بمناو فيزياكا بس هر او نبزانن كهر اتوميك او ايميل تنيش دابو بيالي لاكسايتد ستيتا باش فتري قربقرته غاما ريد بويات بويا زور جاي جالين غاما ري بيوتري تشكي نووي بيوتري تشكل نواتا ويتدرو دواي باسي اكس راي كاين كفرقي تشي لقل غاما ري باشا بتجينا السر أما sliders her information about the atomic structure. Here we have the electric charge of electron, which is equal to 1.6 or 2 times 10 power to minus 19 coulomb, and rest mass of the electron is equal to 9.1 times 10 power to minus 27 kilogram. And these electrons around the electron, we said that the number of proton is equal to the number of electron around the nucleus. These electrons revolve about the nucleus in well-defined orbit. These orbit denoted by KLMN. K is the nearest orbit from the nucleus, after that L, after that M, next is N. According to the principle of atomic model, the number of electrons present in each cell is limited. So we say that the electrons exist on a special orbit around the nucleus. Each orbit contains a limited number of electrons. The innermost of shell, called K shell, has the rank of 1. Any shell with a rank n has maximum allowed number of the electron. We use usually 2n power 2 to calculate the number of electron in this shell. For example, if we are in a shell 3, we say that 3 multiplied by 3, 9, 9 feet, 2, 18. This means that the maximum, the shell 3, which is M, the maximum electron in shell M is contained 18 electron. Usually we use this relation, 2n power 2. For example, hydrogen contain 1 electron in a K shell. Helium have 2 electrons also in K shell, because K shell is the maximum electron in K shell is 2. And lithium has 3 electrons, 2 electrons in K shell and 1 electron remain in L shell. Usually we express the mass of the atom like this. And sometimes we don't use the kilogram, unit kilogram for measuring the mass of neutron, proton, because they are very small. We usually use another unit called atomic mass unit. 1 atomic mass unit is equal to 1.66 multiplied by 10 power minus 27, because kilogram is very big and mass of electron especially is very small, so it's better to express in atomic mass unit. اما سلايدا بزيادة بمان الله شيء او الكتروناني كباس ما كل دوري نواتن دابش بون لهند ان شاء الله كيو ال و ام ان اجمالي او الكترونان لم شيلانيا دياري كراوه هر شيلك ماكسيمم خوي هي مثلا بمها كيشي وثمان حسابك ان دوجا مثلا كي يكا يقليرات تعويزه كان يقدوجا في دو كاتا كي دو اجري ال تنقري اگر دو بي دوهم بي كاتا تشوار هاشتاجري اما هاشتاجري وهكذا دون سين منما بيتتبو هيدروجين وهيليوم ومانا atomic mass unit هي كيكا بكاري هنري for what for measuring وتملبو ماس بكارية دبري كيلوغرام قوري وإما زانين ك بابلين ماسي constitute كاني أو باشا أو structure أو بابلين بارتيكلاني كأتومي بيك يناوكو بروتون ونيوترون وإلكترون ماسا كان يعني بتشوكن دبرو باشتر وين بوحديك بيونتيك كريك بتشوتر بين لكي. This is the representation. This is the figure of hydrogen, helium, and lithium. We see that the hydrogen have 1 electron and 1 proton contain no neutron. Helium we have 2 electron, and lithium have 3 electron, 2 in a K shell and 1 in L shell. This is for more explain. Okay. We go to the radiation. We know that we have different radiation, but before we go to the types, I want to define simply the term radiation. Radiation is energy that moves through space or matter at a very high speed. This energy can be in the form of particles such as alpha, beta, which are emitted from radioactive material, or waves such as light, heat, radio waves, and X-ray and gamma ray. Usually, radiation is energy. We cannot see radiation and smell, so because they are a small particle. This energy moved from one space to another by what? By some particles. This particle may be alpha, maybe beta, and maybe moves with a wave. Usually there are different between, we will talk about it next. Usually there is different physical properties between the two types of radiation. these particles and the waves. Usually we call the light, heat, radio wave, X-ray, and gamma ray are waves, but we say that alpha, beta, electron are particles. This energy moved by these types of particles is called radiation. Okay, types of radiation, we have in general two types of radiation, non-ionizing and ionizing, depending on what? Ability to ionize in water. Matter. Which is mean by the ionization. When any radiation can produce ionization when incident on an atom, it's called ionizing radiation. If the energy or the radiation has not enough energy to produce ionization, is called non-ionization radiation. This is the difference in general between them. The ionization potential of atom, the minimum energy required to ionize an atom, ranges from few electron volt for alkali elements like sodium, calcium, to 24.5 electron volt for helium and noble gas. This means that sometimes, for depending on the element, sometimes we need more electron volt is the unit for measuring the energy. So some types of element require less energy for producing ionization, but sometimes it's called we need more energy for producing ionization. Any type of radiation can produce ionization or excitation is called ionization radiation. If the energy of the radiation is not enough for producing ionization, which is meant by ionization? Ionization means that eject or remove electron from the atom. Eject one electron or more from the atom is called ionization. Excitation means that when the electron is raised from one orbit to another is called ionization. As excitation. Only ionization radiation can produce ionization process and excitation process. Non-ionizing radiation cannot produce these two processes because their energy is not enough for producing these two processes. So this is non-ionizing radiation cannot ionize matter because its energy per quantum is below the ionization potential of atom. Ultraviolet, visible light, infrared, microwave, radio wave are example of non-ionized. You heard about the UV, you heard about the visible light, you heard about the infrared, microwave, radio. All of these radiation are located on electromagnetic spectrum. X-ray and gamma ray also located on electromagnetic spectrum, but only these radiation are called non-ionizing radiation, and this is not our field or subject in radiation biology. But ionizing radiation can ionize matter either directly or indirectly because its quantum energy exceeds the ionization potential of atom. So ionizing radiation have enough energy for producing ionization like X-ray, gamma ray, neutron. You heard about neutron also, electron, proton, and heavier particle are example of ionizing radiation. كواتا راديشن بريتيا لشي بريتيا لا انرجي اجوزريتا ولا شونك وبشونه كتير بلا ام انرجي كي اجوزيتوا عاده يا بارتيكل اجوزيتوا يا ويف اجوزيتوا بشكل كي عام دواي بس شي اكين مالا بس مال لشي ويف ولا قال بارتيكل همو بارتيكلات همو بابلين راديشن اگر او جوري راديشن اگر بارتيكل كايجوزيتو ما بس مال بارتيكل شيا زياتر اوانن كبارجو they have charge and mass. Alpha particle has charge and mass also, beta particle also, electron, proton. But these types of radiation like light, radio wave, X-ray and gamma ray, they don't have charge and mass, so they called waves. In general, we have the usual radiation man هيك يعني بيوترين non-ionizing ما بس ما لشيء أو تشكانن كتوانا يبقى أنكرني أتو مكان يعني شيء ناتوانا الإلكترون ليكنوا وەکو چیە هەموو ئەوانەی کە کەوتونەتە سەر سپێکترەمی ئەلکترۆماگنەتی وەکو UV visible infrared microwave radiowave رادیۆویڤ و مایکرۆویڤ ئەگەر بیرت بێ هەموو ئەو جیهازانەی مۆبایل و ئەو شتانی کە بەکاری هێنی لە ڕێجی چیایە مایکرۆویڤ و رادیۆویڤە بەس ئەمە معنایەوە نییە نەڕازن رادیشن خراپ نییە ئەمیش خراپە ئایستا زۆربەی تاکی دەکرێتەوە کە نابێ بە شێوەیەکی زۆر بەردەوامیش مۆبایل و شتی وا بەکار بێ بۆچی چونکە ئەمانش هەموو ئینێرژین رادیۆویڤ و مایکرۆویڤش هەموو ئینێرژیە جا ئینێرژی ئەگەر زۆر بات و ئۆکیومیلیشن بکات خەتەرە لەو شوێنە کۆبێتەوە بۆیە باش نییە خاستن مناڵ و گەنج بەردەوام مۆبایل بەکار بهێنن لەبەر ئەوم سبەیە بەڵام مۆزوعی منن ئایۆنایزن رادیشن نییە لە ڕاستیە بەسەر هینێکی بخەمە سەر سەرنجێکی بخەمە سەر بۆی جیا بکەینەوە کاتە بە جەماعەتی UV visible و infrared و microwave radiowave ئەوترێت چی non-ionizing radiation because their energy is not enough for ionizing the atom. Ionizing radiation وتمان چی ئەوانن کە ئێنێرجیەکان زۆرە ئەتوانێت ئەلکترۆنت بۆ لێکاتەوە یان excitation بکە excitation ئیسە لە دوای تعریفیشم کردووە بریتیە لە بەرزکردنەوەی ئەلکترۆن لە مەدارێکەوە بۆ مەدارێکی تر مەسەن لە K بچێ بۆ L لە L بچێ بۆ M ئەوە پێوتری excitation ئەمەش هەر ionizing radiation ئەیتوانێت بیکەوت وەکو X-ray و gamma ray و نیوترۆن و ئەلکترۆن و ئەمانە هەم پیانوترێ ionizing radiation. This is the electromagnetic spectrum. If we see that the electromagnetic spectrum is begin with the radio wave, after the microwave, infrared, visible, UV, X-ray, gamma ray. When we go from radio wave to gamma ray, the wavelength is decreases, but the energy is increases and frequency increases. So gamma ray and X-ray are ionizing radiation because on the electromagnetic spectrum, only X-ray and gamma ray are ionizing radiation. Other from radio wave to UV, however, sometimes some sources or some references say that the ultraviolet is included to ionizing radiation because you know UV is from the sun. When we exposed to the light of the sun, sometimes we will get cancer, skin cancer. So it's not good to exposure to ultraviolet also because if you concentrate on the spectrum, each of them have a spectrum of energy. For UV, this line or this energy is near the X-ray is very dangerous. Usually UV is divided to 3 parts, A, B, and C. C is very dangerous because it's near from the X-ray. Okay, X-ray and gamma ray on the electromagnetic spectrum is our subject because only on the electromagnetic spectrum, X-ray and gamma ray are ionizing radiation, and ionizing radiation is our subject in the radiation biology. Okay, in this slide, we explained I explained briefly before, so this is for repeating. Electromagnetic radiation is energy that travels in waves at speed of light. So all of these radiation are waves. They are called photons. Usually photons, they don't have mass and charge. Only like a small particle without mass and charge. So all of the electromagnetic radiation travels in waves at the speed of light, but at the speed of light in space. When they incident on any material, their speed is different from each other, depending on what? On their energy. It includes broad spectrum of waves, like I said, radio wave, microwave, infrared, visible, this is repeat, and X-ray and gamma ray. In this spectrum, only X-ray and gamma ray are ionizing radiation. The others are non-ionizing radiation. All of them are, their speed in space are 3 times 10 power to 8 meters per second and travel in a straight line. These waves are essentially characterized. When we want to calculate the energy of these waves, we have a famous relation called Planck equation, which is energy of the wave is equal to h nu, and this nu is equal to c over lambda. H is the Planck constant. This is the value of it is right here, written here. And c is the speed of light in space. Lambda is the wavelength of the waves. So when we want to calculate the energy of radio wave, microwave, infrared, visible light, and all of these waves on the spectrum, we can use this relation. The energy associated with the inert progressively increased from, as I said, from radio wave. The energy is increased from radio wave to the gamma ray. Gamma ray is the highest energy on the spectrum. X-ray and gamma ray photon can eject an electron from the orbit, so they are ionizing radiation. In next slide, there is also electromagnetic spectrum. All of these are presented how radio wave used in radio, microwave, in oven, and also in mobile and in towers, infrared and used for heating, visible light for light, ultraviolet, and X-ray use usually for diagnosis or for imaging, which is your field, and gamma ray usually used for therapy. The table contain also the name of the radiation on the electromagnetic spectrum, their waves in angstrom, their waves in centimeter, frequency, and energy. You see that the energy is increased from the radio wave to what? Gamma ray. Gamma ray has the maximum energy on the spectrum. Okay, we say now our subject is ionizing radiation, so we concentrate only on ionizing radiation. As I said that the non-ionizing radiation is not our subject, but it's important to have some information about it. ionizing radiation ذات الموضوعية ما non-ionizing radiation تنها ضرورية كخبرية كتابة لسري يعني زور ضروري موضوعية منية بلام چکە ئەو وەکوتیم ئەوش زەرەری هەیە بەڵام زەرەرەکەی خۆی ئەو جیاوازە چکە هەموو ئەم پارتیکڵانە نەن ئاینازیش هەمویان ئەنرژین ئەنرژی ئەگەر بە بەردەوامی بکەوێتە سەر شوێنێک کە کەم بێ و زۆر بێ زەرەری خۆی ئەیە بۆیە ئەڵێن خراپە مۆبایل زۆر بەکار بێت یان زۆر جار مایکرۆویڤ کە بەکارێ زۆر ئێستا هەندێک ڕفرێنسەڵێ باش نییە بە بەردەوامی بەکاری بێنی باش نیە بۆ هەندێک مەواد بەکاری بێنی باشترە بۆچی چکە ئەوانش ئەنرژین باش. We will begin with the types of ionizing radiation. We have two types called direct and indirectly for understanding biological facts. These ionizing radiation, all of them are divided into two types. The types of ionizing radiation, like I said, it includes gamma ray, X-ray, alpha particle, beta particle, electron, neutron, protons, all of them called ionizing radiation. But for understanding, in order to understand the effects of biological effects of this radiation, we should divide it into two types: direct and indirect. Let we see which is meant by direct and indirect ionizing radiation. Both directly and indirect ionizing can transverse human tissue. Both of them include all of them, thereby enabling the use of ionizing radiation in medicine for both imaging and therapeutic. Both of them, directly and indirectly, usually used in medicine, imaging and therapy. Like X-ray, usually we used in different types of devices for imaging, like X-ray imaging, conventional, like fluoroscopy, like CT. All of these devices are used X-ray. And in PET, you know that in positron emission tomography, which is also used for imaging, is used positron and also gamma ray. And some of them are used for therapeutic also. Especially in our center in Suleimani, in Gianawa Center, we have we used for therapy, we use usually X-ray, gamma ray, electron. We have these three types in our center in Suleimania used in what? In therapeutic. So both of them, ionizing and ionizing radiation, depending on their energy and used for imaging in different devices and for therapeutic. Let we say what we mean by direct ionizing radiation. Direct ionizing radiation consists of charged particle, which mean by charged particle. This particle has charge and mass, such as electrons, protons, and alpha particle, and heavy ions. It deposited energy in the medium through direct Coulomb interaction between the charged particle and orbital electron of an atom in the observer. So we have two types directly, which include all of these particles which has mass and charge. When this particle, like electron, let we say that electron incident on an atom. This electron has a charge, okay? When interact with the electron in the orbit of an atom, coming electron and the electron on the orbit, both of them has charge. Both of them has charge and similar charge. We said that the electron has negative charge. So I think you heard about the interaction or when interaction between two types of charge. Similar charge, they repels each other, and the different charge are attracted each other. This attracted and repelled each other called Coulomb force interaction between the charged particle and the orbital electron of the atom in the observer. So the direct interaction between charge with charge is called directly ionizing radiation. Other particle also like proton, like heavy ion, they have also the charge. When incident on the atom, maybe they interact with the electron or with the nucleus. Both of them, electron has negative charge and nucleus has positive charge. When these particles, when charge interact with the charge, if they have the similar charge, they repel each other, and when they have different charge, they attract each other. This is called directly ionizing radiation, meaning that direct their energy transfers to the particle in the atom. By what? By Coulomb interaction. This Coulomb interaction is come from the interaction between a similar charge and different charge. But indirectly ionizing radiation, like uncharged, neutral, mean that include what? Photons. Photon has no charge and mass, but neutron has mass but not charge. Both of them has not charge. So photons, which is include gamma ray and X-ray. In our subject, ionization radiation, which is photon, we mean that X-ray and gamma ray only. And neutron also has no charge. So both of them has no charge, called indirectly ionizing radiation, or sometimes called neutral, uncharged. Mean both of them, neutron and photon. Photons, we mean that X-ray, photons of X-ray and gamma ray. They deposited their energy in absorber in two steps. First step, when they come and incident on an atom, they don't have charge. The first step, they release particle from the atom, and the second step, this secondary particle, which is produced by the first interact with the other atom inside the material. So we call that the first step, the neutral particle release or produce a charged particle. This charged particle, which is produced in the first step, sometimes called secondary particle in the absorber, which in the second step, the charged particle, which is produced in this step, what are they do? They deposited their energy, kinetic energy, through the Coulomb interaction with the other atoms, with the electron in other atoms, in a manner discussed above for dielectric vacuum, like the directly ionizing radiation. Hope it's clear, and I think I explained in Kurdish also. So ionizing radiation دو جۆرمان هەیە بەپێی ئەوەی کە for understanding بۆ ئەوی تێبگەین لە biological effect یعنی کەین بە دوو باشەوە directly نەزانم بە عەرەبی پێوترێ مباشر یان غێر مباشر ڕاستەوخۆ ناڕاستەوخۆ بە کوردی زۆربەی ئەو ionizing radiationانە هەردووچی لە لای ئێمە ionizing radiation فقط بۆچی بەکارێ لە طوبا بەکارێ لە پزیشکیە بەڵام لە وڵاتان بۆ مەجای تریش بەکارێ مەسەڵەن وەکو کارەبا بس لای ئێمە بەس لە طوبا بەکارێ زۆربەی ionizing radiationەکان لە ئیمێجینی شا بەکارێ لەگەڵ تێراپیوتیکا ئەوانەی کە لە ئیمێجینە زیاتر بەکارێ ئێکسڕێ لای ئێمە چکە ئێمە زیاتر ئێکسڕێی ئیمێجینی ئەتیادی بەکارێنی سیتیمان هەیە لەگەڵ فلۆرۆسکۆپی و هەندێک شتی ترمان هەیە مۆمۆگرافی ئەمانە ئێکسڕێ بەکارێنرێ لە تێراپیوتیکا زۆربەیان بەکارێت وەکو ئەلکترۆن و ئێکسڕێ و گاما ئەمانە لەم سنتەری ژیانەوەی خۆمان ئەکسڕێ و ئەلکترۆن و گاما بەکارێت بۆ ئەوەی biological effecti ئەم ionizing radiationانە بزانین ئەیکین بە دوو بەشەوە directly and indirectly directly کە چیە گرێتەوە هەموو پارتیکلانە گرێتەوە کە ماس و چارجیان هەیە وەکو ئەلکترۆن پرۆتۆن ئەلفا پارتیکل هێڤی ئەیۆنز پارتیکل زائد دوی هەیە ئەلفا پارتیکل وەبزەم لە یەکێ لە سلایدەکانە ئیشارەتم پیاوە ئەگەر نەبوو شەرحێکم ئەلفا پارتیکل هینە نەواتی هیلیۆم خۆی دوو ئەلکترۆنی هەیە هەردوو ئەلکترۆنەکە هونەکە بەس نەواتە مێنێتەوە پێوتری ئەلفا پارتیکل هێڤی ئەیۆنەکانیش ئەوانن کە زۆر لە ئەتۆمەکان هەندێک لە ئەلکترۆنەکانیان هونەکەن پیانەوترێ هێڤی ئەیۆن ئەو هێڤی ئەیۆنانە زۆر استفادەی لێکرێ بۆ عیلاج لە in a special center in Europe ئەنجا دایرەکت ionizing radiationەکان ئەوانە گرنەوە ئەمان ئیشیان چییە هەر چارج پارتیکلەکە گەر بێت شەحنەی پێ چارجی پێ باشە لەگەڵ ئەلکترۆنەکانی دەوری نەواتە ئەو ئەلکترۆنانەش چیان هەیە بارگیان هەیە چارجیان هەیە ئەگەر ئەو موجب بوو لەگەڵ سالبە ئەگەر سالب بوو لەگەڵ سالبە ئەمە پێوترێ کۆڵم فۆرس ئینتەراکشن یا لە یەک نزیکەکەونەوە یا لە یەک دوورەکەونەوە بەڵام مهم وەیە نەتیجەی ئینتەراکشنەکە لەوانەیە ئەلکترۆنێکت بۆ دەرکەیان ئینتەراکشنەکە لەوانەیە لەگەڵ نەواتا بێ نەواتیش شەحنەی موجب پرۆتۆن و نیوترۆنی تایە لەوانەیە ئەلکترۆن نیوترۆن بۆ دەرکە جا ئینتەراکشنی چارج لەگەڵ چارجا پێوتە دایرەکتلی یعنی مباشر یعنی ڕاستەوخۆ بۆیە پێ ناوەکەشی لەوە هاتۆ دایرەکتلی ionizing radiation چارج پارتیکل لەگەڵ چارج پارتیکل ئینتەراکشنەکە ئیتر چارج پارتیکل هاتوو لەگەڵ ئەلکترۆن ئابیکە لەگەڵ نەواتابیکە نەفسیشتە هەر چارج لەگەڵ چارج بەڵام indirectly بۆچی پێوترێن indirectly چیشە گرێتەوە فۆتۆنەکانی ئێکسڕێ و گاماڕێ و نیوترۆنە گرێتەوە چکە هەردووکیان چارجیان نییە ئەمانە بە دوو خەتوە by two step they deposited their energy the first step چیەکە چارجەکەی ئینتەراکتەکە لەگەڵ چییە لەگەڵ چارجەک لەگەڵ یا ئەلکترۆنیان نەواتە ئەو کە هاتووە چارجی پێ نییە فۆتۆنی ئەکسڕێ و گاماڕێ یا نیوترۆنە گەر بێت نیوترۆن دایمەن حەزەکە لەگەڵ نەواتە ئینتەراکشنەکە لەگەڵ ئەلکترۆنانایکە بەس فۆتۆنی ئەکسڕێ و گاماڕێ لەگەڵ ئەلکترۆنایکات لەبەرەوە کاتێککە یەکەم شت چییە چارج پارتیکل ریلیزەکە لە یەکەم ستێپە چکە کەیەت چارجی پێ نییە لەگەڵ چارج پارتیکڵە باشە یەکەم ئیشی release a particle produce a charge particle this charge particle is called the secondary particle لە second step ئەو charge particle دروست بووە لە خەتوە یەکەمە لە step یەکەمە ئەو لەگەڵ charge particle-ەکانی ئەتۆمەکانی ترە ئینتەراکشنەکەات بۆیە لە خەتوەی دووهەمە ئەبێتەوە بە دایرەکت وەکو ئەمە جیاوازێکی نێوان hope it was clear so ionization is the process of removing one more electron from atom by incident radiation leaving behind electrically charged particle and electron and positively charged ion, which may subsequently produce biological in the radiator. So the process of ionization means that the move of rejected one electron or more. As a result of ionization, produce one electron and the atoms become positively because they lose in electrons, and both of them electrons when is ejected from the atom and the ion which this ion is produced as a result of the ionization reaction, both of them have different biological effect in the irradiated material. This material may be tissue, cell or others, but excitation if the energy is not enough for this is the ionization. When an electron, let we say, when an electron is incident on an atom contain different number or a large number of electron, when they have enough energy to remove an electron, this is called ionization. But when the energy of this electron is not enough for ejecting the electron, maybe this electron rises from one state, from one orbit to another. This is called excitation. Only ionization radiation can produce ionization and excitation process. Non-ionizing radiation has not enough energy for producing these two types of process. So if the energy transferred by ionizing radiation to an atom is insufficient to eject orbital electron, the electrons may be raised from a lower to higher orbital, and the atom is said to be excitation process. The ionized or excited atom or molecule may either fragment, producing free radical, or return to the parent. These both the atom, the excited or ionized atom, both of them are dangerous in any place, or maybe the electrons was ejected may be returned to the parent, and the atom will be neutral in this case. كاتا ionization process excitation تنها ionization radiation أتوانا بيكا أجر أو مثلا بونو من لا رسمة أجر الإلكترونيك بيد بتواند لأتوميكا كشباريكي زول الإلكترونيتيا لي كاتوا أو بيوتي ionization radiation ionization عمليكا بلان أجر إن طبعا إنرجيكا بيويستا بو ionization زياتر لو زورتر لو إنرجيكا بيويستا بو excitation أجرو إنرجيكا بأتوميكا هاد بابلين أولا نبو بتوانيت شكا بيرمانتشي all of these electrons has binding energy. We should overcome this binding energy in order to liberate this electron. The electrons near the nucleus need more energy for ejecting. So if the energy is not enough for liberated or ejected, maybe this electron is raised to other state or from one orbit to another, called excitation. ليرة باب وستين ساعات يكا حزناك مشتكان زور زخد بلا سرطان ليرة أوستم بۆ ئەوەی نازانم کەس حەزەکە پرسیار بکات ئێستا ئەگەر جواب بینەوە یان هەر کەس پرسیارێکی هەبوو تا ئێستا هەفتەی داهاتوو لە فیزیکس ئۆف ئەکسڕێ رادیشنەوە دەست پێکەین ئینشاءڵڵا هەر پرسیارێک دێ لەمەی کە ئێستا شەرحم کرد ئەتوانی بیکەی وەکو وتیشم ئەگەر ئێستاش نایکەی ئەتوانی وەکو ملاحەزە بینویسیت و هەر کاتێ نازانم بەس نازانم کەیینەوە هۆڵەکان ئەتوانی بیکەی ئێستاش ئەتوانی پرسیار بکەیت هەر کەس پرسیاری هەیە لو أتي برسيارت أنا بباب تشينا سر attendance زانين attendance بزام كي هاتو كنا هاتو لراستيا ضرورية شرحانة ولي وداريشم أو شتاني كبوتان أن يرم بيخنو بجواني ويقر هالبرسياركتان هبو للاتان دروزو وكو ملاحظة بينوسم باشا لا تندسكي أمر وياك ششي مانجا لافين هاتوا هنا كانت أن بكنا وزحمة